All right, guys. Well, thanks for joining us today. The people online that I can't see. We're here to talk about energy audits and explain how they help building owners and managers both compile up-to-date building systems information and operations information, report energy breakdown information, determine how much energy, what portions of their energy are being spent on different areas, whether it's heating or lighting or ventilation, and to identify opportunities for facilities to reduce their energy use and help to identify cost-saving measures that are actually feasible for that particular building to use. That's not working. This isn't clicking forward, so. That'll work. I'll just use the keyboard. So why look at building performance? Well, first of all, in the United States, buildings account for approximately 39% of overall energy use and 72% of electricity consumption. And commercial buildings use about 20% of all of the energy used in the United States. So it's a pretty big number. Of that 20% of that energy, for office buildings, it's estimated that up to 30% is wasted on an average per building. So it's definitely an opportunity for savings. So why focus on existing buildings? Well, while there's undoubtedly a lot of potential for new construction, 80% of the buildings that will be here in 2050 are here today. So it's also more sustainable to retrofit and restore existing buildings than it is to build new construction. So we spend 90% of our time inside of buildings, which is a huge part of our lives. So it should be something that we're concerned about, not only from the energy side, but also from our health and wellness. And EnergyStar calculates that a 10% reduction in energy can equate to about a 1.5 increase in net operating income for commercial office buildings. So that's a pretty big significance. So a 2011 study called The Economics of Green Building found that on average, every dollar of energy savings yields about a 3.5% rent premium and a 4.9% boost in market value for that particular building. Recent data also demonstrates that LEED certified or EnergyStar labeled buildings charge about 3% higher rent and benefit from higher occupancy rates, and they sell typically for 13% higher than conventional buildings. Overall, buildings that have implemented green or sustainable measures typically achieve about a 6.6% overall return on their investment. So we'll get to the portion of the presentation where we talk about how to better go about managing your energy and what types of tools you can use. In order for commercial buildings to move towards energy efficiency and overall sustainability, there needs to be a solid commitment made. In Pittsburgh, you may have heard of the 2030 District or the 2030 Challenge, which is a very clear and determined voluntary way of committing to reduction in energy. And those buildings that have signed up for those challenge, they're definitely on the forefront of demonstrating that they're making that commitment. Next, you need to find out where you stand. This is where you create benchmarks of your energy, water, waste usage, or you can have an energy audit or retro-commissioning study done to find out where you stand now. And lastly, you want to identify and evaluate improvements that might be feasible for your building and your building's occupants. And they should be evaluated both from the hard costs and hard benefits or hard impacts and the soft side of things, the reflections on occupancy comfort, the reflections that are harder to necessarily put dollars and cents to, with improved employee productivity and environmental health concerns. In order to control energy efficiency and reach toward energy and sustainable goals, there are three major areas of focus that have to be considered. And those are energy efficient purchasing, which of course we want to make sure that we're purchasing energy at the lowest cost possible. In Pennsylvania, we can take advantage of deregulated utility programs, so we have the ability to negotiate and bid out our energy costs. We also want to consider efficient equipment. So when it makes sense to upgrade or replace any existing equipment in place, we want to make sure that the most energy efficient versions that still satisfy the needs of the occupant are considered, and that their initial costs, operating costs, and maintenance costs are all considered in that value proposition rather than just a first cost scenario. And lastly, you always want to consider efficient operations and maintenance. We need to ensure that the equipment in place and the building's usage overall is being used in the most energy conscious and sustainable way possible. So a great tool to work on all three of these areas is an energy audit, which we're here to talk about today. So an energy audit analyzes the current energy performance of a building, and it identifies cost-effective saving measures, energy saving measures, that can be implemented. The final product of an energy audit is going to be a report that summarizes that information. So what's the purpose? The purpose of an energy audit is to map out, like we mentioned before, where you stand now and where there are opportunities of improvement, and what you can expect in terms of costs and savings for those different opportunities. There are really two clear purposes. Like I mentioned, the first is to understand how your building is currently consuming, and secondly, identify how that consumption can be reduced in an economical manner. Well, some energy efficiency upgrades can be considered pretty well no-brainers. How you structure those investments can be critical to how well you spend your upgrade budgets. For example, sometimes the sequence of implementing different measures can affect the successfulness of the implementation and the ROIs that you're going to see from those. Planning smart investments can also help to take advantage of the savings from one to help fund another. So now I'd like to take a few minutes to walk you through what the energy audit process is like. First, we start with a pre-site visit. So before actually coming out onto the site, it's useful and the best use of everyone's time to get a lot of information to your energy auditor. We recommend using a minimum of 2 years of energy bill data, so energy consumption data. If you haven't been in the building for that amount of time, then there are ways of extrapolating some data or possibly looking to past tenants to see if you can use some of their data. However, that 2 years of data really gives you a good picture of where you stand, and you're able to normalize it over time and identify anomalies in the data prior to getting on site that you can be watching for. This is a pretty important part of an audit because, for example, in one building that I went to, I hadn't seen the data ahead of time, and once I looked at the data afterwards, I found out that the top floor of a building was using 3 times the amount of natural gas as the lower floors. So that doesn't make sense in an office building, in a typical 6-story office building. So if I would have known that about the data ahead of time, I would have had more of an idea what to look for and spend my time on site doing. With that data, you want to also benchmark the building. And that is where you gather a sense of how well your building is performing relative to other buildings. And we normalize that energy consumption with weather data, because we don't always have winters like this past winter, and we don't always have winters like the winter before this winter, how mild that winter was. So we need to consider how the weather impacts our usage as well. And gathering information on the building prior to going out on site gives the auditor a better picture of how much time to spend in different areas, what types of usage, building usage to expect, what areas are occupied at different times of the day, what types of systems are in place. You may want to find out how those systems have changed over time, if they've had any major retrofits, or if they've had any major issues come up down the line, or if any of the systems are currently non-functional. That's good to know before coming on site so that you can expect to troubleshoot those areas or skip those areas if they're not an issue or a brand new system that really isn't being looked at as a replacement. The more familiar an auditor is with the building, the better their time is spent on site. Next, we typically recommend using EnergyStar Portfolio Manager to help establish your benchmark for energy and water. The reason that we do this is it's a free online program for everyone to use, and they also compare your data with the CBEX database. Portfolio Manager also makes it easy to normalize for weather and to compare to other similar buildings by helping you to develop both an EUI, which is an energy use intensity, which means the energy used per square foot of your building. So it transfers the units that are used for electricity and the units that are used for gas into a general unit. And then it makes that an easy to compare number from building to building. Then EnergyStar actually gives you a score of 0 to 100, with 100 being the absolute best and 1 being, well, having a lot of opportunities for improvement. So performing your energy audit, the next step is doing your walkthrough, doing your building walkthrough. And this is going to, the depth of this part of the study is variable depending on the level of your analysis and how many building systems you're looking at. So if you're looking at all of the building systems, they can include the envelope, the lighting, HVAC, domestic hot water, and any other major systems of the building. During that walkthrough, it's critical to have time to sit down and talk with the facility manager or whomever is constantly running the building, whether it's, even if it's an outside vendor that takes care of any HVAC issues that happen in the building. It's good to schedule some time to sit down and talk to them about recurrent problems that are happening with the system, complaints that are happening, what equipment run times are, whether there's setbacks, what the set points are for different points of equipment, and what your schedules look like. And it's also important to talk with the occupants. Sometimes this could be limited in a commercial office building. Sometimes the owners don't want you to be walking around all the desks and asking people how they feel in their space, because I know if you did that at our headquarters, you'd get a lot of complaints. But in general, if the more that you're able to get some feedback from the occupants, the better. Improving the occupancy comfort is a key thing to keep in mind while you're trying to improve the efficiency of your building. So the next step is taking all of the data that you gather during the building walkthrough phase, and that could be testing the equipment, it could be those surveys, interviews, and analyzing it. This is where you start to look through the energy bills for consumption trends, where you calculate the energy consumption and break down what portions of the overall energy are being spent on different areas of the building, whether it's lighting or cooling or ventilation or plug loads, different uses of the building, and every building is going to be different. If your energy audit includes model building, whether it's a spreadsheet model or it's a more in-depth Department of Energy endorsed modeling software like eQuest, this is where you would input all of your data into that modeling program and run it with any possible upgrades that you were looking at. And this is where you identify and evaluate any energy conservation or energy saving measures. And for each of those measures, you want to consider all of those categories. The feasibility of the measure, how feasible is it really to install that particular measure, whether it's occupancy sensors or a new boiler or what have you. It has to be able to fit in the space. It has to be operable. It has to be able to be managed by the people in the space. You need to consider the annual energy savings from that energy conservation measure, first costs as well as operational costs. So are the operational costs going to increase or decrease over time? And operations and maintenance costs, how expensive is it going to be to maintain the unit? Are you going to be changing the filters 10 times more often than you did before, or does the unit have reusable filters that you can clean and reuse? And what are the occupancy, comfort, and health results from those energy conservation measures? So this is an example of a breakdown, that estimated energy use, end use breakdown for a commercial office building. As you can see, a big chunk of it is used for space heating and cooling and ventilation. And then another big one there is lighting. On this particular one, it's 25% for lighting, 10% for other. So other can include some of your plug loads and security systems. A lot of times we don't get the energy data from security systems, usually off limits. So that usually ends up in the other category. Then the last step of your energy audit process is to build your report and then to present that report. And the report should include at minimum a very accurate and up-to-date building description, how the building's used, what's in the building, what systems it has, and what models, what units, what serial numbers, all of the information that you gathered during your walkthrough. The energy end use breakdown that you calculated, as well as discussion of the past consumption bills and any trends in the data or any anomalies in the data that you've seen. A prioritized list of recommended energy conservation measures. And I say prioritized because that takes into account when I talked before about making those smart investments and being able to capitalize on the savings from one investment to use for another, as well as the implications of putting into place one energy conservation measure with or without another. For example, if you're doing a lot of envelope improvements on your building envelope, it could make an opportunity for you to downsize your boiler or downsize your air handling unit. It could also cause you to need to bring in more outside air, more ventilation. So you might have to run outside air fans a little bit more often. So you need to consider those implications with your report and energy audit. The prioritized list should clearly communicate your ROI analysis, how you came up with the return on investments. It should have your initial costs, your operational costs, what kinds of savings are associated with each measure, the impact of those measures on operations and maintenance procedures, and the impact on the building occupants, whether it's going to make them more comfortable, give them more control over their systems, sometimes give them less control over their systems in the case of occupancy sensors or daylight sensors. And you also, in every energy audit report, you also want to list the energy conservation measures that you considered but that are not recommended and why. Because, and this is important because in future things change, whether it's the building usage, the building itself, or the people in the building, technology, costs may come down, and this report should be something that the building owner, facility manager can refer back to and see, oh, we considered geothermal heat pump systems, but at the time, this was their cost, this is how much it was going to cost to implement them. Now, we have these rebates and incentives available, and it brings down that initial first cost, so the ROI makes sense. So making sure that you include those, whether they're recommended or not, and why, is important. So there are several energy audit guidelines in existence. The most commonly used is called the American Society of Heating, Refrigerating, and Air Conditioning Engineers. I never remember that whole acronym, but everyone refers to it as ASHRAE. So ASHRAE has a guideline procedure for commercial building or commercial energy audits. It is a guideline. It is not a standard. It's not written as a standard, so it's not extremely particular as to what's included in the different levels. It has 3 levels, and it increases in depth with each level. So level 1 is the most simple, and that's a walkthrough analysis, which should typically take like a 1-day visit on site. Level 2 is an energy survey and analysis, and this is a much more in-depth audit. Typically involves a lot more testing of equipment and a little bit more in-depth study of your energy conservation measures. It can include energy modeling, but again, the ASHRAE guidelines don't specify. It says it's optional. And a level 3 is really when you want to look into doing a massive retrofit option, whether it's bringing in green energy or sustainable energy options like wind turbines and solar, geothermal, whether it's a full lighting retrofit, that could be a level 3 project. A building recladding project, that could be part of a level 3 project. A level 3 almost always includes an energy model. Some other common guidelines are the BPI technical standards for multifamily building analyst professional. And like that title is kind of self-explanatory. It's mostly for multifamily buildings. But it's another good reference for if you're building a spec for an energy audit or you want to see what's included in multifamily versus office spaces. And a lot of people go for customized scopes with their audit. If every building is different, obviously every person is different, every company is different, and the age of different systems are different. So if it makes sense to jump right into a level 3 project, but really only analyze lighting for your building with a very basic energy and use breakdown, then that's more of a customized scope project. So it can be customized. They're, like I said, they're guidelines. They're not standards. They're up for interpretation. And I will step through a little bit more of the level 1 or of each level. So the first level is a walkthrough. It's a basic energy audit. It can be a good starting point if you haven't addressed your energy consumption in the past and you really don't know where your building stands, and you're not looking at making a larger investment into analyzing where your building stands. It includes identifying low and no cost energy saving measures and identifies some more capital improvement projects that should be studied in more depth before implementing. It definitely goes over your utilities. It has a full bill audit section, and you want to make sure that you use a benchmarking kind of program to determine what your energy consumption is now and what your target consumption can be. So level 2 is called an energy survey and analysis. It's a little bit more detailed than a level 1, and it's usually the most appropriate level for buildings, for most buildings, especially commercial buildings. The breakdown of energy use is included in this as well, but it's much more precise than that in a level 1. In a level 1, it's much more estimated, whereas in a level 2, it's much more measured, and you spend a lot more time on site in a level 2 than you do in a level 1. It could also include, your breakdown could also include more end categories. So it would include things like computers, servers, whereas level 1 would just include your broad categories like lighting, heating, cooling, ventilation, etc. A more thorough analysis of your energy consumption is performed, and unlike a level 1, the operation and maintenance procedures are also reviewed, and if there's any suggestions, they would be made in that case. After the initial analysis is completed with the auditor, the building owner, facility manager is typically brought together for a closeout meeting where you can go through the findings so far, what you want to look into a little bit further as those capital improvement kinds of projects. And then it not only identifies your low and no cost measures, but it goes more in depth into identifying and prioritizing those potential capital improvement projects and the savings and costs that are associated with those. So then there's the level 3 energy audit, and this is also known as the investment grade audit. And this is the level that I mentioned before for more major renovation projects where you're changing out an entire system or majorly renovating the building, and you want to make sure that all of the systems are going to work with your new layout if it's completely changing the space. It has very detailed field data gathering, a lot more measuring and monitoring of the systems, a lot more just data gathering time spent on site, and focuses on those capital intensive projects. So now that you know what an energy audit is, how do you go about finding an energy auditor? There are a few engineering organizations out there that have begun to offer energy audit certification. The most commonly recognized and the older certifications out there are from the Association of Energy Engineers, and the two associated with energy auditing in particular are the CEM, the Certified Energy Manager, and the CEA, the Certified Energy Auditor. Both of these certifications have prerequisites for sitting for the exam. They have to be experienced in their field. They have to have a certain amount of years in their field. They have to have relevant degrees. And they sit for pretty involved tests to ensure that those people with those designations have qualification to be working in the field. And ASHRAE has also recently released a building energy assessment professional, which is directly related to energy audits, especially with commercial building energy audits. There's also, for multifamily buildings, as I mentioned BPI before, BPI also has a multifamily building analyst professional, again, focused on multifamily buildings because they can be very different than commercial office buildings. The systems are more similar to residential systems generally than in a commercial office space. You want to be cautious of free energy audits because, like you know, Mom and Dad always said nothing is ever really free. There's no such thing as a free lunch. However, if it is free, there's nothing really that you can hurt by getting a free audit. You just have to make sure that you look over it with a grain of salt. Most of the time, a free energy audit is being given by a vendor that's trying to sell you something after the fact or remodel whatever it is that their expertise is in. So you just want to make sure that you thoroughly evaluate those reports. They can oftentimes be a great stepping stone, though, if you're looking into a particular area. It's also important whenever you're looking at energy auditors to ask for a sample report for a building that's similar to yours. So if you are a library, ask for other auditors that have done buildings like libraries or libraries in the past, and see if you can see their reports. And as always, just as if you were interviewing someone for a job, you want to ask for references. Everyone should be able to provide references on past projects. And who is a good energy audit candidate? So what makes your building a good candidate for an energy audit? So an existing building, definitely. A building that's less than a year old, it doesn't really have enough energy data, energy consumption data, to really evaluate for an energy audit. It's best to have a minimum of 2 years of energy data, like I mentioned before. And the recommended is to have, it's best to have at least 12 months. You have to have at least 12 months of continuous data, but 2 years is usually the best minimum range. So a lot of what you're analyzing in an energy audit relies on your history of consumption in order to find out how efficient your equipment is in place. If your building has had a lot of changes in building use, whether the systems in place have been there for 50 years and the tenants have changed out 10 times, it's usually a good signal that the building systems that have been there aren't really designed to provide for the occupants as they're using the space. So that's usually a good indication for an energy audit. And if you've done a benchmark and you recognize that your building's in that lower range on the EnergyStar Portfolio Manager score, or if your EUI is a high EUI, then compared to similar buildings, then it might be a good opportunity to look into an energy audit. And those who have never had an energy audit done before, typically there's savings that you can get, whether it's from a low-level energy audit and there's low and no-cost things, or if you want to look into more capital cost improvements. So my final thought is that an energy audit is not going to save you money on its own. It's the actions that come out of an energy audit and out of that information that's provided by an energy audit that give you those full benefits. It provides you with the knowledge of how your building's operating currently and what kind of potential there is for improvement. So if anybody has any questions, you can talk about the process, procedures.
I have a question. You might have already covered it already, so I can answer that later.
Sure.
But I was curious, buildings, of course, are different to do before, but I'm curious what the rule of thumb or a good range for what an audit costs for level 1, 2, and 3 on a per square foot number.
Sure. That is a very common question. She asked how much audits cost for level 1, level 2, level 3 on a per square foot basis. So I have a lot of involvement with ASHRAE. And I actually sit on a technical committee with ASHRAE that designs the guidelines for energy audits and is creating a standard. And that's a topic of discussion that always comes up in our technical group with a lot of auditors. Well, what do people charge for a level 1, level 2, level 3? And it is extremely wide. the same people that charge for a level 2 sometimes charge for a level 1, and it's all because of those guidelines being so optional. It's really dependent on who's providing the service. But I would say just in flat numbers, not really on a square foot basis, a level 1 energy audit should be for a, let's say, a 50,000 square foot office building. I would say a level 1 audit is going to be around 2,000 at the minimum to could be 8,000 to 10,000, depending on how complicated it is. If it's historic landmark building, it could be very complicated. A level 2, as I said, there's going to be a lot of overlap. So level 2 could be anywhere from $4,500 to $15,000, and then a level 3, which again, a level 2 can include building energy modeling. If modeling is included, then your price is going to go up a lot more. A level 3 typically always includes energy modeling, and those are, like I said, investment grade audits. So they're when you're already looking at making a major renovation, and those can go across the board depending on what you're looking at. If you're looking at a building envelope renovation, it's more based on the time spent on the audit than the square footage and what building systems are in place. So it's hard to give you a number for that one. Anybody else? Yeah?
Do you see retro commissioning having a place within an energy audit, or do you see that as always separate?
Retro commissioning is oftentimes a recommendation that comes out of an energy audit because they are separate things. Retro commissioning includes testing and balancing of the systems and really fine-tuning them so that they're working as per the building occupant's needs. And most level 2 to level 3 energy audits consider retro commissioning as one of the implemented measures. There is a little bit of overlap between the two in that in both you want to consider your operations and maintenance procedures, you want to consider or you want to take down the information on your building systems in place. But with retro commissioning, you're not looking at making major retrofits with the building. You're not looking at making changes, whether it's a boiler change or changing out your air handler, changing the size of your air handler. None of that's included in a retro commissioning project. Retro commissioning is really just making what you have in place work the most efficiently as it can while doing small changes, whether it's valve changes, filter changes, testing and balancing, like I said, resetting your set points. A lot of times the controls, just doing the retro commissioning on your building systems controls, especially if you have an energy management system in place, that can be a major source of savings with the retro commissioning project. So it's usually in the category of the capital investments for an energy audit. Sure.
I have another question. So kind of specific related to ECM, and I'm interested in you're doing an analysis and reviewing and prioritizing those recommendations, if those guidelines that you use regarding how long these measures can actually last, you know, how many years it can last, and where you get that information, and also what degradation factors you kind of use thinking about, you know, it's not going to be it and
Sure. Well, a lot of it is based on industry knowledge. A lot of it is based on our seeing the building systems in place and understanding how fans and motors degrade over time, and that a refrigerator only lasts for so many years, a hot water tank typically only lasts for so many years. A lot of that is like common industry knowledge. But there are... No, it's a lot from your experience. It's from having those experienced auditors that have done 50, 100, 150 audits, seen the equipment in place, tested it several times, especially like anybody that's done retro commissioning in the past. They've had a lot of experience with different ages of equipment and how well they're performing at different ages of their cycle. It's also important to find an energy audit that has good relationships with vendors in different areas so that they can talk to them about degradation factors of equipment. So that if you have a Train unit, your energy auditor can reach out to that particular person and say, okay, I have a unit, it's 35 years old, but it looks like it's performing pretty efficiently. How long should this last? Or I'm looking at recommending this size of a unit. What is the typical life expectancy of your particular unit? It's a lot of researching in the field, a lot of the background work of an energy audit, whether it's their own knowledge being out in the field or whether it's reaching out to their networks, where everybody can't be an expert at everything. So an energy audit isn't manufacturing all of that equipment. They're not maintaining all of those equipment pieces on a regular basis. So having that network for your energy auditor is critical. So,
sure. That a little bit. This is a term called persistence, and that is, you talk a little bit about technology of the equipment over time instead of degrading. There's a broader term called persistence, is how well the occupants and the maintainers and the repairs take care of the system once they've been updated. That usually has a bigger effect. Meaning you can put in a more efficient motor, but if you leave the motor on all the time, it's not running very good.
Sure.
Or if you change the purpose of the motor to move the air around the room, but instead of having 20 people in the room, now we have 2 people in the room, you don't need a motor running at the same speed. So the behavior tends to be a large part of the flow system, how well the changes really last over time.
Absolutely, and that's a lot of where in energy audits and in retro commissioning as well, looking into how the building is operated and maintained and taking the time to do those interviews with facility managers as to how much are they adapting what they have in place in order to satisfy the occupants. How often is, this lady in the corner office complaining about not having enough heat, so you've rerouted some heat to her space or close off a bunch of vents in other areas where now they're all falling asleep because they're not getting enough outside air. So there's a lot of things that come up over the lifetime of the project, like you mentioned, that affect your energy efficiency a lot more than degradation of equipment. But going back to degradation of equipment, that part of your ROI analysis is going to vary with different energy auditors that you speak to as well. And that really is going to depend on industry knowledge, experience with the equipment, et cetera.
Is there like a need for standardizing any of that, or giving like a rule of thumb across the energy auditor 1 versus 2? Like I could get very different numbers based on maybe degradation factors, not just equipment, but the extra the other 2.
Well, it really is part of making sure that you do your homework on that particular energy auditor. It's not, there's not really going to be a standard, like ASHRAE is not going to publish a standard saying that all hot water heaters seem to start to decline at age this, and this is their lifetime.
So like rules of thumb or like guidelines even.
Yeah.
There are some guidelines in terms of lumen.
Yeah, lighting, a lot of those do.
But they don't tell you that is how well you clean the lens in front of the lens. That affects degradation as well. So
as well as how often is it turned on and off, and is the room kept at what temperature? Because if you have an LED light and it doesn't have a great heat sink, but your room is always cooler than usual, that LED is going to last longer than the LED in the hallway where it's getting a lot more outside temperature influence. So situational, and again, it comes down to experience. And absolutely, manufacturers make a difference. If you go with one manufacturer for one fan unit and another manufacturer for another, they're going to have different life expectancies. So being out in the field and knowing what you've seen in place then you see an average and you're better able to recommend what's really expected as life expectancy. So.
I think Auditor has published some data, at least on HVAC equipment or life expectancy.
There's some white papers.
Pardon me?
There's some white papers out for different equipment.
Operations and maintenance guide some years ago. It had the major HVAC, like how long you could expect a chiller to last and a rooftop unit in there. So if you dig, you'll probably find that.
Sure.
But it's so dependent on the things we talked about. These are just averages.
Mm-hmm.
At the beginning of the presentation, you talked about energy savings as one, maybe most common reason for energy audits. There's many others: cost savings, carbon footprint reduction, maintenance issues, supplier requirements.
Absolutely.
From the people coming into RCX over the last few years, who's coming to you? Are people looking to really save energy, save dollars? They're required by their municipality to get energy savings. Who's coming to you to ask for your services?
Well, so far it's been a combination. I would say the majority are looking to save money. They're looking at their energy costs going up annually, that their bills are getting higher every year, whether it's because their building's getting older and their systems are getting older, or whether it's a combination of that and utility prices going up. People see that they continue to go up in the future, that it's expected, so it's mitigating that risk. And that's one of the main driving factors. The other, I would say, the other major one deals with competition, competitive factor, making sure that you're the best one on the block, or if this person's being sustainable and issuing a corporate sustainability report, then your competitor needs to do it as well. So it seems, for us, it seems to come from those two particular angles. We have had a few that have come to us and said, I know that there are rebates out there for VFDs, and I want to find out if VFDs are an option for me. And in those particular cases, we usually do like a smaller scale analysis. It's not a full-blown energy audit. It might be like a level 1 energy audit with like going into more of a level 2 on specifically their motors and drives and fan units, things like that. So I don't know what you've seen in the field, but it seems to be that energy savings is still that number one.
There's already an answer, right?
Yeah.
Many of you offer some different services there.
Yep.
And different people come to energy audit for different reasons.
Yeah, absolutely.
And that changes over time. 10 years ago.
It does.
Now, big difference.
Absolutely. 10 years ago, most people didn't know what an energy audit was. It was educating them as to what to expect out of an energy audit, whereas today, a lot of facility managers that you speak to, a lot of building owners, when you speak about building energy audits, they at least have some idea that you're coming into their building to analyze for energy efficiency. Whereas 10, 20 years ago, they had no idea. It's like, don't touch my bills. So times changed, definitely.
What have been some of the more surprising things you found here at the energy audit?
Wow.
You talked about the floors being so different, or the other things like that.
Oh, so being an energy auditor, and especially doing retro commissioning, you're basically like a detective for the building. You're trying to find out why something is happening or why somebody's always not comfortable. And we had one project where this poor lady was always freezing cold in the winter, and she was never cold enough in the summertime. And everybody complained about her. She was, like I said, in a corner office, and the rest of the people around her in her offices were all complaining that they were always having to put their heaters on too much or their air conditioning too much. Well, we found out doing retro commissioning in that building, we tested and balanced the HVAC system there, and we found out that no one had ever taken the wrap off of the duct that came into her office. So she was never getting any air. The only air she was getting was like through infiltration. So like what was coming in from outside and what was coming in from like common spaces. So it's like just one silly, stupid thing that happens during the construction process when they're pushed to get done as quickly as possible, and their bonuses are based on how fast they can put the building up, then you're going to come up with issues like that. I've also run into, there was an exhaust fan in a parking garage that kept turning on, and the facility manager just could not figure out what was going on with this exhaust fan. Well, the sensor was on, the entire inside of the fan was flipped around the other direction. So it was, whenever it was like hot outside, it was starting to pull hot air into the garage space, and instead of like pulling exhaust air out of the space, it was really a major mess, and he had no idea. Like, it just didn't occur to him that the fan was pulling the air into the space instead of exhausting it. So it's things like that that sometimes it takes an outside pair of eyes to look at and to dig into a little bit more, somebody that has some time to do that detective work to find the cause of some of those issues. Like I said, there was that one tenant, 3 times the amount of natural gas on the top floor than the rest, and it's the top floor of an office building. They should be using 3 times the air conditioning, if anything. But no, it was that they were never setting back their heat in the evening. That was one of the factors. Another was that most of the exterior offices had operable windows, and they were all opening their windows because it was too hot outside. They just didn't, a lot of it came down to how they were, like you said, operating the space. They didn't understand how the building system was designed very well, and they were trying to put out fires in their area and, you know, deal with what they had as best as they could. So you end up seeing some really unusual things, and like we keep emphasizing, every building is different, every facility manager is different, their experience levels vary, and especially with the last 5 to 10 years of advancements in technology, advanced control systems, a lot of automation, people don't think to go back and recalibrate CO2 sensors to make sure that they are actually reading and that they're actually feeding back information to the building control unit. We had a gymnasium that had these great occupancy sensors all over the building to regulate their outside air, and they had never been programmed into the controls unit, never since the beginning of the building. So it was an 8-year-old building, gymnasium, bringing in 100% outside air during all seasons. So you end up finding a lot of things like that where savings from something like that is enormous, and they already had the sensors in place. It was just a matter of programming them. So you can find a lot when you're doing these studies.